Pluto is a crime scene. For 76 years, we called it a planet. We put it in textbooks, hung it on classroom walls, gave it a spot at the end of every solar system model sold in every toy store in America. Then, in 2006, we stripped that title away, and most people stopped paying attention. They figured the story was over. A small, frozen rock at the edge of the solar system, demoted and forgotten. That is the version of Pluto most people still carry in their heads, and almost none of it is true. Because while we were busy arguing about what to call it, Pluto was busy being one of the most geologically violent, chemically complex, and scientifically confusing objects we've ever encountered. And when New Horizons finally got close enough to see it clearly, what it found didn't just surprise scientists, it broke their models. The first thing you need to understand about Pluto is where it lives. It orbits the Sun at an average distance of about 5.9 billion kilometers. That's roughly 39 times farther from the Sun than Earth. At that distance, sunlight is about 900 times dimmer than what we feel on a summer afternoon. Noon on Pluto looks like deep twilight here. The temperature at the surface sits around -230 degrees Celsius. That is cold enough to freeze nitrogen solid. Not into a liquid, solid. The air itself becomes rock. For decades, every model we had said the same thing. At that temperature, at that distance, with a body that small, roughly 2,377 kilometers across, smaller than Earth's moon, Pluto should be dead. Geologically inert. A frozen ball of ice and rock with nothing happening on its surface, nothing happening underneath, and nothing interesting to say. That was the scientific consensus going into 2015. Pluto was a relic, a leftover chunk of debris from the formation of the solar system, sitting in the dark, doing nothing. New Horizons arrived on July 14, 2015, after a 9.5-year flight. It passed within 12,500 kilometers of Pluto's surface at a speed of about 49,600 kilometers per hour. The encounter lasted only a few hours. The spacecraft couldn't slow down, couldn't orbit, couldn't go back. It had one shot to collect as much data as possible, and it did. Over the next 15 months, New Horizons transmitted everything it had gathered back to Earth, and piece by piece, the old version of Pluto fell apart. The first image that stopped people cold was Sputnik Planitia. It's an enormous plain of nitrogen ice sitting inside what appears to be an ancient impact basin on Pluto's surface, roughly 1,200 kilometers across. From a distance, it looked smooth, almost featureless. That alone was strange, because a surface that smooth, in a place that old, meant something was actively erasing craters. In a solar system where most small, cold bodies are covered in impact scars billions of years old, Sputnik Planitia had almost none. The surface appeared to be less than 10 million years old. On geological timescales, that's yesterday. When the high-resolution images came back, the smoothness turned out to be an illusion. The plane wasn't flat. It was divided into irregular polygonal cells, each one roughly 10 to 40 kilometers wide, separated by shallow troughs. They looked like the cracks on top of a cooling pot of oatmeal, and that comparison turned out to be closer to reality than anyone expected. The cells are convection patterns. The nitrogen ice in Sputnik Planitia is slowly churning. Warmer ice from below rises to the center of each cell, spreads outward, cools, and sinks back down along the edges. The entire plane is turning itself over like a lava lamp running in slow motion, completing one full cycle roughly every 500,000 years. On a world that was supposed to be frozen solid, the ice is moving. That raised an obvious question. Where is the heat coming from? Pluto has no tidal heating. It's not being squeezed and flexed by a giant planet the way Europa or Enceladus are. It has no significant source of external energy. The sun is barely a bright star from its surface. The only explanation that fits is internal heat, residual energy from radioactive decay in Pluto's rocky core. But Pluto is tiny. A body that small should have lost its internal heat billions of years ago. The math didn't work. And yet the convection was right there in the images, undeniable, doing something that the math said shouldn't be possible. The geology didn't stop at Sputnik Planitia. New Horizons found mountain ranges made of water ice, some of them rising 3,500 meters above the surrounding terrain. Water ice on Pluto behaves like rock does on Earth, because at those temperatures it's just as hard. These mountains weren't eroded stubs. They had sharp edges, clean faces, the kind of features that suggest they formed relatively recently, maybe within the last 100 million years. Something pushed them up. Something was still building terrain on a world that should have gone quiet 4 billion years ago. And then there were the glaciers. Not water ice glaciers, nitrogen ice glaciers. Pluto has flowing rivers of frozen nitrogen that creep down from the highlands and pool into Sputnik Planitia, the same way glaciers on Earth flow into valleys. They move imperceptibly slowly, but they move. They carve channels. They leave flow marks. On a world where the temperature never climbs above -220 degrees Celsius, there are active glacial systems reshaping the landscape. I want you to sit with that for a second. We have trouble keeping roads intact through a single winter in the Midwest. Pluto is running an active geological resurfacing program at temperatures that would freeze oxygen into a solid block. To understand why all of this matters, you have to understand where Pluto came from. It's a Kuiper belt object, one of potentially hundreds of thousands of icy worlds drifting in a vast ring of debris beyond Neptune's orbit. The Kuiper belt stretches from about 30 to 50 astronomical units from the Sun, and for most of the history of planetary science, everything in it was assumed to be inert, cold, dead, and uniform. Just rubble left over from the solar system's construction. Pluto was supposed to be the largest piece of that rubble, nothing more. The New Horizons data demolished that assumption so thoroughly that it forced a rethinking of the entire Kuiper belt. If the biggest object in the belt turned out to be this complex, this active, this alive, what about the rest of them? What about Eris, which is roughly the same size as Pluto and orbits even farther out? What about Makemake, or Haumea, or Sedna, sitting out at the fringes in its 11,000-year orbit? We have almost no close-up data on any of them. We've been assuming they're boring because we've never bothered to look. Pluto also forced a quiet reckoning with one of the core assumptions in planetary science, that size determines complexity. The conventional wisdom was straightforward. Big worlds do interesting things. Small worlds cool off, freeze solid, and stop. Mars is bigger than Pluto, and it's geologically dead. Mercury is bigger, and it's geologically dead. The Moon is bigger, and it's geologically dead. Pluto was supposed to be the most dead of all of them. Instead, it turned out to be the one still actively reshaping itself. Nobody has fully explained how a 2,377-kilometer-wide ball of ice and rock, receiving almost no solar energy, manages to sustain the kind of geological activity that much larger worlds gave up on billions of years ago. The existing models of heat retention and radiogenic decay don't produce enough energy. Something else might be going on, and we don't know what it is yet. Wright Mons changed the conversation entirely. It's a feature in the southern hemisphere of Pluto, roughly 150 kilometers across and about 4 kilometers tall, with a central depression at its summit that looks disturbingly like a volcanic caldera. When the New Horizons team first published the images, they were cautious. They called it a possible cryovolcano, a volcano that erupts not with molten rock, but with a slurry of water ice, nitrogen ice, ammonia, and methane. The caution was warranted. Claiming volcanic activity on a world this small and this cold was an extraordinary statement. And extraordinary statements need extraordinary evidence. The evidence kept arriving. The terrain surrounding Wright Mons has almost no impact craters, which means it was resurfaced recently. The texture is unlike anything else on Pluto's surface, lumpy and hummocky, consistent with material that was extruded from below and then froze in place. Nearby, a second feature called Wright Mons shows similar characteristics, though it's even larger. Together, they suggest that Pluto didn't just have geological activity in the distant past. It may have had eruptions within the last few 100 million years, and some researchers think more recently than that. If you could somehow stand near Wright Mons, you wouldn't see lava. You wouldn't feel heat. You'd be standing in near total darkness, on terrain that crunches like packed snow, looking up at a mountain that once vomited ice into a sky so cold that the erupted material froze before it could flow very far. A volcano made of ice, on a world that shouldn't have the energy to boil water, let alone push it through kilometers of frozen crust. Honestly, it's one of the most alien landscapes we've ever documented, and we found it on a rock most people forgot about after a naming dispute. The atmosphere was another shock. Pluto has one. It shouldn't, given its size and gravity, but it does. A thin envelope of nitrogen, methane, and carbon monoxide that extends up to 1,800 kilometers above the surface, far higher relative to its size than Earth's atmosphere extends above ours. New Horizons watched the sun set behind Pluto and saw the atmosphere light up in layer after layer of blue haze. The blue color comes from tholins, complex organic molecules formed when ultraviolet light from the sun breaks apart methane and nitrogen in the upper atmosphere, and the fragments reassemble into larger, more complicated chains. These tholins drift down to the surface and coat everything in a reddish-brown stain. That distinctive ruddy color Pluto has in every photograph isn't rock. It's organic chemistry raining out of the sky. The atmosphere itself is unstable in a way that makes it fascinating. As Pluto moves along its 248-year orbit, its distance from the Sun changes significantly because the orbit is highly elliptical. When Pluto is closer to the Sun, the surface nitrogen ice sublimates, meaning it transitions directly from solid to gas, and the atmosphere thickens. When it moves farther away, the atmosphere starts to freeze out and collapse back onto the surface. Pluto is essentially breathing, inhaling its atmosphere, then exhaling it, on a cycle that takes nearly 2.5 centuries to complete. Scientists had predicted this cycle, but what they hadn't predicted was the complexity of what happens during it. The atmospheric pressure at Pluto's surface, measured by New Horizons, was about 1 Pascal. That's roughly 100,000 times thinner than Earth's atmosphere at sea level. Weak by any standard. But within that thin envelope, New Horizons detected wind patterns, temperature variations with altitude, and distinct haze layers stacked on top of each other like the rings of a tree. A world with barely any air at all
had weather. What makes that weather even stranger is what it does to the surface. Pluto has dark streaks on its terrain that align with prevailing wind directions, the same way sand dunes on Earth align with wind patterns. In 2018, a team of researchers published findings in the journal Science, arguing that these features are wind-deposited ridges made of methane ice grains. Dunes on Pluto, built by winds that blow through an atmosphere 100,000 times thinner than ours. The grains are lofted not by wind force alone, which would be far too weak at that pressure, but by sublimation. As nitrogen ice turns to gas on the sunlit side of surface features, the escaping gas kicks methane particles into the air, and the faint winds carry them downwind until they settle. It's an entirely new mechanism for dune formation, something never observed or even theorized before New Horizons saw it. Now take all of that, the convection, the mountains, the glaciers, the cryovolcanoes, the atmosphere, the dunes, the organic chemistry, and add one more thing. Pluto may have a subsurface ocean. This is where it gets genuinely unsettling. Analysis of Sputnik Planitia's location and Pluto's gravitational field suggests that beneath the nitrogen ice, beneath the water ice bedrock, there could be a layer of liquid water. The basin is almost perfectly aligned with the tidal axis between Pluto and its largest moon, Charon, which is exactly where you'd expect excess mass to accumulate. One way to get that excess mass is a dense liquid layer under the surface. And liquid water mixed with dissolved ammonia, which acts as antifreeze, fits the data. A study published in 2019 proposed that this ocean might have existed since Pluto's formation, protected from freezing by a layer of gas hydrates, essentially a blanket of frozen gas molecules trapped in an ice crystal lattice, sitting between the ocean and the surface ice shell. This insulating layer would slow heat loss enough to keep liquid water stable for billions of years. If that model is correct, Pluto has maintained a hidden ocean for nearly the entire history of the solar system, longer than complex life has existed on Earth.
If it's there, this ocean would exist in permanent darkness, insulated by a thick shell of ice, kept liquid not by the sun, but by the faint trickle of heat from Pluto's core. It would be one of the most isolated bodies of liquid water in the known solar system, a reservoir that has never seen sunlight, never been touched by solar wind, possibly never been disturbed by anything since it formed. That isolation is what makes the ocean so interesting to astrobiologists. We tend to think of life as requiring sunlight, warmth, a protective atmosphere, Earth-like conditions. But every decade, we discover organisms on our own planet that break those rules. Microbes thriving in total darkness at hydrothermal vents on the ocean floor. Bacteria living inside Antarctic ice sheets. Entire ecosystems running on chemical energy, not solar energy. If Pluto's ocean has a rocky floor, and if that floor is even slightly warm from the core's residual heat, then you have the same basic ingredients that support chemosynthetic life in Earth's deepest oceans. Liquid water, mineral-rich rock, and an energy gradient. Nobody is claiming there's life on Pluto. That would be absurd given the current evidence. But the fact that we can't rule it out, on Pluto of all places, tells you how badly we misjudged this world. A decade ago, suggesting Pluto might have habitable conditions would have ended a career. Now,
It's a legitimate area of research. Charon deserves its own mention because it complicates Pluto's story even further. Charon is enormous relative to Pluto. At roughly 1,212 kilometers in diameter, it's more than half Pluto's size. The two objects don't orbit the way the Moon orbits Earth, with a smaller body circling the larger one. Pluto and Charon orbit each other around a point in space that sits between them, outside of Pluto's surface. They're locked face to face, each one always showing the same hemisphere to the other, spinning around their common center of gravity like two dancers holding hands. Some scientists don't call Charon a moon at all. They call it a binary partner. Charon's surface told its own story. New Horizons found a massive canyon system stretching across its equator. Some of the chasms running more than 5 times deeper than the Grand Canyon. The northern pole was coated in a dark reddish cap that scientists have informally named Mordor macula. The leading theory is that methane gas escaping from Pluto's atmosphere drifts over to Charon, gets trapped at the cold pole, and is then processed by ultraviolet light into the same tholins that coat Pluto's surface. Pluto is painting Charon with its own atmosphere. The system includes 4 other tiny moons as well: Nix, Hydra, Kerberos, and Styx. All of them small, irregularly shaped, and tumbling chaotically through space. Their rotations aren't stable. They spin in unpredictable ways because the gravitational field of the Pluto-Charon binary is itself complex and shifting. Living inside this system would mean looking up at a sky that never behaves the same way twice. What gets me is the scale of the revision. Before 2015, Pluto fit neatly into a simple narrative: small, cold, dead, demoted. Every part of that was wrong. It's small, yes, but it's running an active geology that rivals some bodies 10 times its mass. It's cold, but that cold drives processes we've never seen anywhere else in the solar system. And dead? Pluto is more geologically alive right now than Mercury, than the Moon, than most of the rocky worlds we've studied up close. The demotion almost certainly played a role in how long we ignored it. When the International Astronomical Union voted in 2006 to reclassify Pluto as a dwarf planet, public attention shifted away. Funding conversations moved to Mars, to Europa, to Titan. Pluto became a punchline, the planet that wasn't. Alan Stern, the principal investigator of the New Horizons mission, never accepted the reclassification and has spent years arguing that the definition used to exclude Pluto was poorly constructed and scientifically inconsistent. Whether or not you agree with him, the data from his spacecraft made one thing clear. Whatever you call Pluto, it is not boring. It is not simple. And it is absolutely not dead.
There is already discussion about a return mission, an orbiter this time, something that could stay and watch Pluto change over months and years instead of photographing it in a single frantic flyby. The concepts include nuclear-powered spacecraft that could study the atmosphere across seasons, map the surface in detail, and potentially confirm or rule out that subsurface ocean. One proposal, informally called Persephone, would carry instruments specifically designed to measure the thickness of Pluto's ice shell and listen for the gravitational signature of liquid water beneath it. None of these missions have been funded yet. The distances involved are staggering, and the travel time would be measured in decades, not years. But consider what a single flyby revealed. A world we thought we understood turned out to be one of the most dynamic, complex, and frankly baffling places in the solar system. Nitrogen glaciers, convecting ice plains, organic rain. Mountains of frozen water standing like granite. Ice volcanoes that erupted in total darkness. Dunes built by winds that shouldn't be strong enough to move anything. An atmosphere that breathes on a 248-year cycle. And possibly, deep beneath all of it, an ocean that has been sitting in the dark since before anything was alive on Earth. We spent 76 years thinking Pluto was a planet, then 9 years arguing about whether it deserved the title, and exactly 0 years understanding what it actually was. The argument over the name was always a distraction. Pluto doesn't care what we call it. It's out there right now, 5.9 billion kilometers away, doing things we can't explain, on a timescale we can barely comprehend, in a darkness we'll never fully penetrate. And the most unsettling part isn't any single discovery. It's the pattern. Every time we've sent a spacecraft to something small and cold and far away, something we assumed would be boring, it turned out to be extraordinary. Enceladus, Titan, Triton, and now Pluto. Which means every other icy body we haven't visited yet, and there are thousands of them out past Neptune, could be hiding the same kind of complexity. We've barely scratched the edge of the solar system, and the edge is already more alive than we ever imagined. Thanks for watching, and I'll see you in the next one.